Hello, I'm Jason with ScienceandMath.com. Today we're going to do a really neat experiment, and the way you would phrase it when talking to somebody would go something like this. You would have a bucket of water and you would say, look, I can take this piece of paper here and I can put it underneath that water, underwater, inside this tub, underwater, and this paper will not get wet. And they'll look at you and say, how do you plan to do that? And you'd say, well, let me show you. So all you need for this experiment is a bucket of water or a sink or a bathtub, anything to hold water. You need a glass. You don't necessarily show them the glass ahead of time though. And you'll need just a regular old sheet of paper. It could be a paper towel, could be a piece of paper from the printer. And so what you're going to do is you're going to put the paper underwater all right, but you're going to put it inside this cup. And the way you do it is you want to crumple this paper up, but you don't want to squeeze it too tight. You just want to crumple it just enough to fit inside this cup. See how I fit it in there? And then what you want to do is kind of push it to the bottom, like this. So if you've done it right, it should be in the bottom of the cup and it shouldn't fall out whenever you turn it upside down, okay? Now, you go over to your bucket of water and you hold it upside down as flat as you can and you gently push it all the way under water. So the cup is completely underwater. And you count to 5, let's say 1, 2, 3, 4, 5, and then you gently lift it up. And then you go tap any excess water off of there. And then you gently reach in and pull your paper out, which is completely and totally dry. It is not wet at all. And so you've won the bet, right? So you go ahead and get paid up for that. Now, the way this works is really interesting. So what you have when you put any kind of cup upside down underwater, it kind of looks like it's filling up with water, but it's really not filling up with water. It is full of air. So there's air inside this cup, right? There's air all inside this cup. And whenever you put it on top of the water, there's air pressure inside of this cup here because there's air in there. That just means the air is pushing against the walls, pushing against, the inside, pushing out. Anytime you have air in there, you have air pressure, right? So that's trying to make the air come out, but there's this water underneath it, and that water is trying to come in. And so you have a balance of the forces. You've got the inside air pressure, trying to push the air out. So it's trying to expand and push the air out, but you have the water pressure underneath. The water's trying to come in. And those two things are more or less balanced right now. And so that means that the air is going to stay on the inside, the water is going to stay on the outside. We always think that the water is going to force its way in, but it can't just force its way in. It has to be able to overcome the air pressure. So again, it's a good example of why you can look at a real life situation and understand that air really does push with a force that we call air pressure. If it didn't push, then the water could just come right in. Now look what happens whenever I gently tilt this cup. When I tilt it, some of the air can actually come out and bubble up the side, and then some of the water can rush in. So if I go underwater and I gently tilt it, then I get lots of bubbling. And then of course, I have the water going into the cup. Now another thing you can do, you can go underwater with it. You can let water in, like we do, and I think most everybody here has probably done this in the bathtub at one point. So now we have the glass of water underwater, and it's completely filled with water, right? So there's no air in there at all anymore. Now, whenever we lift it up, right, just above the water line, then what we have here now is the glass is full of water, but the glass of water, the water is not, it's not leaking out, and it's not going back into the container of water. Why is that? It's exactly the same thing. It's pressure. So there's water inside of here, and that water has weight, and it's trying to push its way out through the bottom. But there's air pressure all around this entire vessel of water. The air pressure is pushing on top of this water and trying to push its way back into the cup. So you have an inside force, the gravity pulling the water down, and you have an outside force which is pushing on the top of this water here, trying to force it, basically force it back up inside, and those two are in balance. And so everything is in check until you just lift it barely out of the water to let some of that air in and some of that water to go out, because as soon as you lift it outside the water, then basically the air is allowed to come in. That pressure is allowed to become, there's no pressure anymore because there's no water anymore. So it's kind of two experiments in one. First, you put a dry glass, dry piece of paper in there, and you didn't say exactly how you would do it. You just bet somebody that you could put a piece of paper underwater, submerged, and it would stay dry. And that's exactly what you did. You put it underwater and it stayed dry. You created a pocket of air where there was pressure inside that kept the water out, right? And then the other thing that we did was we filled it up with water and raised it up, and sort of a similar thing happening. The outside air pressure is pushing on the water on the outside, keeping that water inside of this cup whenever you lift it up. So very simple stuff to do, but always take the time to make sure you understand what's actually happening. And that's what we did today. So go grab these materials, have fun with them, and have fun showing people that you know a little bit about air pressure and how you can use it to take a piece of paper, put it underwater, and have it stay dry.